Sweet, time for the review of function transformations paper. On this first sheet, we got some multiple choice questions. Given f of x, describe what will happen to the function if replaced by f of x plus 5. Well, if you got a function and you add 5 to all the function values, it's going to get translated up 5 units. On 2, when you got subtraction inside, it's going to move it left or right, so you got a horizontal shift here. And inside, when you subtract, it's moving it right, and when you add, it's moving it left. So subtracting 4 is going to move this function right 4 units. When you put a 3 in front of the function, you're taking all the y values and timesing them by 3, and so it's going to give you a vertical stretch. And an inside, if you have like 1/2 x, you're going to take all the x values and divide by 1/2. Well, if you got any number and you divide by 1/2, you're going to get that number times 2. And so it's going to make it bigger. So we're going to have a horizontal stretch. On 5 through 10, when you describe what happens to the function if replaced by the given function, well, on 5, we got two transformations going on. We got this 1/2 out front of the function, and that you're going to times all the y values by 1/4, so we're going to get a vertical, that's going to be a vertical shrink. And if you got a 2 inside, you're going to divide all the x values by 2, so we're going to have horizontal shrink. Okay, so vertical shrink, horizontal shrink. This guy, we're going to times all the y values by 2, which would give us a vertical stretch. Whereas if you then subtract 6 outside, okay, so subtracting outside, you're going to have a vertical shift of 6 units. Oh, negative 6 units, so it's going to move everything down 6. And then on 7, the 1/7 out front, you're going to times all your y values by that, so we're going to get a vertical shrink by a factor of 1/7. And adding 3 inside is like taking all the x values and moving them left 3. So we're going to have a horizontal shift, and it's an amount of negative 3. Moving on to 8, the negative out front of the function is going to do a reflection. So it's going to reflect over this one, since it's outside. It's going to reflect over the x-axis. And then the +1 part is going to do a vertical shift. A vertical shift of +1, because it's taking function values and adding 1 to all of them. On 9, we got the negative out front, which is going to do a reflection over the x-axis. If you had it inside, that'd be a reflection over the y-axis. But the 3 also is going to stretch the function, so we're going to have a vertical stretch. On 10, the negative inside is going to do, it's going to reflect over the y-axis, because it's flipping all the x values. And the 2 is going to give us a horizontal shrink, because we're going to divide all the x values by that 2, so we got a horizontal shrink there. It's going to make them all smaller. Moving on to the next few here. If you have a function here and it's translated vertically 5 units, what's the new y-intercept? Well, you need to know what the original y-intercept is. This is the equation of a line. We have mx plus b. The b part's your y-intercept, so this originally has a y-intercept of 2, but when you move everything up 5 units, and so we're going to do 2 plus 5, we're going to get a new y-intercept of 7. And then on 12, this is an exponential function, right, 3 to the x, but it's already been translated up 3 units. Originally, exponentials have a y-intercept of 1, but when you move it up 3 like there, it's going to have a y-intercept of 4. And so now we need to take that 4 and translate it vertically -1 unit. So that 4, you need to subtract 1 on, and our new y-intercept is going to be 3. And that's going to be the first video.